Hello everyone. I hope everyone is good. Everyone is fine. So we are again back with another our rapid revision session for the next chapter, that is classification of the elements and periodic properties. We all study it as the periodic table and periodic properties basically. Now, first of all, let's talk about that why this periodic properties and this periodicity was even needed. Now, periodic table is a tabular display of the chemical elements. There are a few introductions. It is the tabular display of the chemical elements. I hope everyone you know that. We all are very much, we all know that what is what to say periodic table. Now, arrangement of the atoms of elements in tabular form according to their properties such that elements can be studied in a systematic form. Why what was the need of this? Because as we know that there are lot many elements in this nature. Now, because they all of them, many of them had the same kind of chemical and physical properties, and there were lot many periodic trends were there. Something was increasing, something was decreasing. So these things, just to understand these things better, it was need of the hour that we should make or we should classify them in that way. So there were many of the historically trials were there, or there were many of the scientists tried to classify them. And in for that what are the different models we have seen in the whole respect. We have seen that, like we all know that Triad's rule is there, there are Newland's octave rule is there is Lothar-Meyer curve is there, or Mendeleev's periodic table. But the problem with all these four, whatever the models I have told you, all these periodic table or period, whatever the laws were there and these models were there, they all were based on the atomic masses, and they considered that physical and chemical properties of the elements are proportional, or they are the periodic functions of the atomic masses. But in reality, what happened? There was a scientist named Moseley who was doing all those X-ray spectroscopy and those things, X-ray diffraction experiments he was doing. And in that way, what he found out that whatever the X-rays of different elements he was getting, their square root of the frequency was directly proportional to the Z. Z is here nothing but it is atomic number. Later on, it was found out that the Z is nothing but it is the number of proton that is present inside the nucleus. Okay, so this was something that paved the way towards the new, or you can say the modern periodic law. And modern periodic law says that physical and chemical properties of different elements is the periodic function of their atomic number, not the atomic mass. Now, how did this all happen? We are going to study about this, and then we are going to study about many of the new different, or you can say different periodic properties. Now, periodic classification follow a logical sequence of the electronic configuration of atoms. Whatever is the modern periodic table, it depends on the Borsbury model of whatever how we fill the electrons inside the atom. Now, what is Moseley's experiment? Because we have to understand, I am not talking about history, because you can see that in the whole syllabus there is no history is mentioned. Now, Moseley's experiment, I have already told you, it was between the root nu, that is square root of the frequency, and the atomic number Z. And we can see that there is a straight line relationship. So what we can say, and what was that formula? It was nothing but root nu equals to A, that is you can say it is a constant, Z minus B. B is also a constant. This was the equation, or this was the form. That is how we have seen that. Now, modern periodic law is the physical and chemical properties of the elements are periodic function of their atomic numbers. Next. Now, this is something that I hope everyone you are very much understand, and you know about these things, familiar with all these things. I hope you also know that what are these things? These are different elements that is periodically classified. Now, what we call them, I hope you all know that. How do we say? Because by now we have studied about that Moseley's periodic law, right? Or you can say that modern periodic law. But here now we are going to talk about that how did this new, that whatever is the form of, you can say, long form periodic table or modern periodic table is there, how we have classified them. We have classified them on the basis of, because we all know that once we have understood how to do the electronic configuration in the atomic structure, we have already studied about it. Whatever was the final, or you can say the last electron was going into whichever subshell. Let's say it was it was going into S subshell, then the whole substance or that element is called as the S block element. Then if it is going in the P, then it will be called P block elements. If the last electron is going in the D, it will be called D, and if it is going into F, it will be called F block elements. I hope you all know that this is nothing but this is S block element, S block elements. So we all know that these are, except hydrogen, we can say that these are, we know that lithium to cesium, these are alkali metal, while beryllium to radium, it is nothing but, or you can say from lithium to francium it is alkali metal, from beryllium to radium it is alkaline earth metals. Now what are P? We can see that these all are P block elements. Now here helium is mentioned, but helium is not P block element, so please just leave that. Why? Because helium has the last electron present in S. But why do we keep helium there? Because helium is from the noble gas family, that's why we have kept that. But please remember that all the noble gas belong to P block element, but helium does not. Helium belongs to S block. No, very important point. Now all these are known as noble gases. Now what is the last element present in the periodic table? That is oganesson, that is 118. Next, here we can see that what are these? These are nothing but D block elements. What we can say, it is the first group, second group, third group, fourth group. You can see that up to, it will be coming up to 12th, and then it will be 13, 14, 15, 16, 17, and it will be 18. Now these are the groups. So how many of the groups we have in the modern periodic table? There are 18. And what is that? The horizontal lines that you can see, that this is nothing but it is periods. So how many periods that we have today? We can see 1, 2, 3, 4, 5, 6, 7. Do not see them, because of course you have to see that, but these are, they are called F block elements. Now these are lanthanoids. They are lanthanoids, and lanthanoids belong to 6th period, while these are actinides, and actinides belong to 7th period. I hope it is not a big deal. You all can see that and you can all understand it. Why are they called lanthanides? Because after lanthanum, they are all lanthanoids, because they are start from after lanthanum, and here because it is starting after actinium, so they all are called actinides. Not a big deal. Now, and these are what? F block elements. So I hope you understand what is S, P, D, F block elements. Next, description of the periods. I hope we all know that about the different periods. In the first period there are how many elements? 2. That is because in the first, you can say first shell, how many of the subshells are there? 1. And which subshell is this? S. And in S subshell, how many electrons you can fill? Only 2. So S1, S2, 1s1, 1s2. So how many maximum number of elements are possible? 2. Which are these? Hydrogen and helium. Similarly, as you go on towards the second, third, fourth and different periods, you keep on seeing that the number of elements are increasing. How and what are they? Can you see that in the first period it will be n equals to 1. In second period is n equals to 2. So period is nothing but it is telling about the principal quantum number, maximum number of principal quantum number. So please keep in mind, not a big deal, but you can understand it. Now in third one, 3, n equals to, in fifth, 5, 6, 6, 7, 6 and 7, 7. You all understand it. What are the different elements we have here, and what are the different names of these periods are given? It is shortest because there are minimum number of elements are there. Then there are 2 short, that is second and third period, and then fourth and fifth are called long, and then comes longest, that is 6th, while 7th one is incomplete. Though we all know that now we naturally to not, but human made, we have got almost, you can say, 118 elements, but they all are laboratory formed. They are not the naturally occurring substances or naturally occurring elements. So we all can say that there are 2 longest, 2 long, 2 short, and 1 shortest period is there. Okay, now we are going to talk about the long form modern periodic table. What are the different characteristics? It is based on the Bohr-Bury electronic configuration concept and atomic number. 7 periods and 8 vertical columns, that is groups, are there. Now according to IUPAC, 18 vertical columns are named as first to 18th group, not a big deal. Next, elements belong to the same group have same number of electrons in the outermost shell, so their properties are similar. So that's why That new periodic law is nothing but it also says the same thing only, right? Next, now in the modern periodic table, the period indicates the value of what does period? I have already told you right now. What is that? It is principal quantum number. Yes or no? Next, the basic difference between Mendeleev's periodic law and modern periodic law. I have already told you that up to Mendeleev's periodic table, that was yet by that time, Mendeleev's periodic table was one of the most successful periodic table. The reason was that it was based on many of the experimental data, but still it was a failure. The reason was that it was based on a wrong concept, and the concept was that chemical and physical properties are periodic function of atomic masses, but it was not the reality. So what we know that Mendeleev's periodic law was based on A is based on atomic weight, yes. B is based on atomic number, yes. It is correct. So it is correct. Next, statement 1. In modern periodic table, position of isotopes of an elements are different. Is it so? No, because it only talks about the element. It does not talk on the basis of atomic mass, because we know that two different isotopes have the atomic mass different, not the atomic number different. So if the atomic number is same, their place will be same only. So it is a wrong statement. Next, statement 2. Alkali metals as well as hydrogen have one electron in their valence shell. Yes or no? I hope we know that. Therefore, hydrogen is placed in the group of alkali metal. Is it so? Please remember one thing. Of course, when we show this, or in many of the cases, whenever we make the periodic table, the hydrogen is kept here. But always remember, you never say that hydrogen has its position in the 1, or you can say this in this alkali metals. No. Still, hydrogen has no fixed position in modern periodic table. So its position is not yet fixed. The reason is its resemblance of the property with metals, that is alkali metals, as well as with the halogens. So please remember these things. So what we can say, therefore hydrogen placed in the group of alkali metal, no, it is a wrong. But still we keep it in the 1s. The reason being that yes, because it has 1s1 electrons. So what we can say that both of the statements are incorrect. So option B will be the correct one. Next, modern periodic table is based on atomic number experiments which proved importance of atomic number. Atomic number was, with what was that experiment? I hope you all remember Moseley's work on X-ray spectrum. Next, consider Moseley's experiment equation root nu equals to 3 minus z. Find the slope of root nu versus z. Can we just make it as y equals to mx plus c? Try to make this. Can we not say that root nu equals to 3z minus 3? So is it not looking something like it is nothing but y, and it is nothing but z, it is x, and it is what? M, and it is what? C. So is it not looking like y equals to mx minus c? So what we can say, m, that is slope, is nothing but 3. So what is the answer? Correct option is option D. Any dikkat? No. Very good. Now, nomenclature of the elements with z is more than 10. When the z is more than 300, whenever there is something like that, we have to understand most of the elements are human made, and their names, though their names are named on many of the different scientists. The question this time from JEE Mains has also been asked. In NEET also, once the question is asked from those names, so I really do not say that it is something a good type of question, but if such kind of question comes where rote memorization is needed, please, you have to go through it now. But still, there is a IUPAC rule is also made for their name, though their whatever real names are there, it is there in NCERT. Please go through it, or you can just go through any of the periodic table. Please go through it and just check it once. Next, what are these names given? You have to just follow. Let's say there is 1 0 0. So it is 1 is for un. Can you see un? Then 0 is for nil. So you'll say un nil. One more 0 means un nil nil. At last you have to just add em. Em is there for the positive, or you can say positive character. So what we can say? Not about just that. We can directly say that un nil nilium. So what will be the element? Un nil nilium. So 1 0 0, right? Let's say, so you understand it. U is that 0 for nil, it is for un, 2 for bi, 3 for tri, 4 quad, 5 pent, 6 hex, 7 sept, 8 oct, and 9 is n. So please remember these numbers. And these things, sometimes abbreviation is also used. So n for nil, u for U for un, B for bi, T tetra, Q quant, P pent, then H hep, S sept, hex, sept, oct, and N. Okay. Now, what would be the IUPAC name symbol for the element with atomic number? This. So it will be un, bi, nil, un, bi, nil, unbinil, unbinilium, unbinilium. You can say U, B, N. Yes, of course, A is the correct one. Next, what we can say? Go with that. UUB is symbol. Now U is for un, one. U means un, and B is for bi. That is 2. 1, 1, 2. So 1, 1, 2 is the option D. Not a big deal. बहुत easy है भाई. Next important point, in the some of the important point, we have to remember few things, that due to the you can say that E by M charge by mass ratio, okay, E by M also, charge by mass ratio, we have got that there are few diagonal elements that show almost same kind of properties, like lithium and magnesium, beryllium and aluminum, boron and silicon. We know that, and it is where it is shown. It is shown in the second and third period, not in the third, fourth, fifth. No, it is only there in the second and third period. Now, lithium to magnesium, beryllium to aluminum, and boron to silicon. Please keep in mind, though they are not in the same period, they are not in the same group, not in the same family, but still they show same kind of property. It is known as, can you see that it is diagonally they are having, so therefore it is called diagonal relationship. So they may ask you question that which of the following show diagonal relationship. Can you just tell me, or can you put the correct option there? Very good. Next, now important topics mein second part is number of gaseous elements, number of liquid elements, and number of solid elements. You have to keep in mind how many of the gaseous elements are there, that we have already found out. Hydrogen, nitrogen, oxygen, fluorine, chlorine, noble gas, these things are there. How many are there? 11. While in liquid, how many? 6. Cesium, francium, gallium, mercury, Br, and UUB. So these things you have to remember. But one more thing I will tell you, that if you talk about that which of them are liquid at STP, or you can say normal temperature and pressure, if you say, so please remember it is only, you can say that here we get with the mercury and bromine. All other, if you talk about, if you talk about all other, they become liquefied at, you can say, 30 or more than 30 degrees Celsius. That is less, that is more than 27 degrees Celsius, but still you can remember these. Then bromine is the only non-metal which exists in liquid form. All other are metals. Okay. Metals of solid elements 95. If discovered elements are 112. Okay, not an issue. You all can see. Now general characteristics of S block element. Now we are going to talk about S, P, D, F, all these different elements. Now the elements is the last electron will enter in the S subshell. That's why S block elements. S subshell can accommodate maximum of 2 electrons. So that's why there are how many of the S block? 2 groups are in S blocks. Their general formula is NS1 to 2. So NS1 or NS2. Okay. Now N belongs to 1 to 7 here. Remember this. Next, total number of S block elements are 14. 7 in you can see in the lithium family, and 7 in beryllium family. You can see that francium and radium are radioactive elements, while hydrogen and helium are gaseous elements. You can just keep this in mind. Cesium, francium are liquid elements, belong to the S block. Please keep this in mind. Next, general characteristics of P block elements. What are the general characteristics of P block elements? Now see, the last electron goes in the P. Now in the P block elements also, which group it belongs to, this will tell you that what will be the name of the group. Now just check that once, that what are these? Can you see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, then 13, 14, 15, 16, 17, 18. So which are P block elements? From 13 to 18 are P block elements. So from 13 to 18, 18th group it is P block elements. Please keep in mind. Next, we are going to talk about what are their other names. We also call it 1A, 2A, because they are what? Main group elements. Main group elements are only, they are only S block and P block element. Which are main group elements? This P, S and P block elements. So they are main group elements. So their name is given by A. So it is given 1A, 2A. Then directly come to 13 will become 3A, 4A, 5A, 6A, 7A. But once you come here, it will say 8A. Oh, what is that? It is nothing but noble gases. But what are D block elements called? D block elements are generally called transition elements. Transition elements except zinc family, or you can say zinc, cadmium and Hg. If you just leave them, So rest all of them will be transition, while all the F block elements are called inner transition elements. These are very important key points to keep in mind. Why are these zinc, cadmium and Hg are not considered as the transition element? Because we know that for transition elements, the last, you can say two shells should be incomplete. You can say the one that is outermost and one is penultimate shell. But we know that in these zinc, cadmium and Hg, penultimate shell completes, you can say n-1 d10 is completed. That's why what we can say, they do not have penultimate shell, you can say vacant, or it is completely filled. That's why what we call them, we do not consider them as the what to say, transition elements. While copper, Ag, Au, because they are made or they are used in coin making, or they used to be used for making the coins. That's why they were also called as, they are also known as coinage metals. Okay, now let's go to the point that we have studied, that we are studying. Now let's talk about it. The general formula for p block elements is this. Okay, not a big deal. Here n is equals to what? 2 to 6. Okay, next, the zero group elements having general formula ns2 and p6 are inert because their are energy levels are fully filled. Now the total number of p block elements in the periodic table is 30. Okay, now in the p block elements we have non-metal, metal as well as metalloids. All of them are there. So please keep in one thing is always in mind, that what are the metalloids, and all the metalloids belong to p block elements only. So please remember, what is that? You sometimes see them as the, as you will see, they will looking like stairs or steps. You can see that it is all yellow color, B, Si, Ge, As, Te, astatine and Po. Take polonium also into it. Okay, so what are those metalloids are there? Metalloids are those substances which have their physical and chemical property between metals and non-metals. So they have both the types of property. That's why they are called metalloids. So metalloids are submetals. So what are they? You can just remember as a, there is one jingle, Auntie Teri Sabji Puri Basi. Auntie Teri Sabji Puri Basi. So Auntie, it stands for AT. Auntie Teri, tellurium T. Sabji, antimony Sb. Sabji, Ge means Ge, germanium. Puri, that is Po. Basi means stale. B stands for boron. Basi is arsenic. Si for silicon. So these are few of these, or not few of them, but all of these metalloids. But you can just remove Po out of it, not a big deal. So what we can say, Auntie Teri Sabji Basi. Because sometimes polonium is taken, sometimes it is not taken. So you may take it, or you may, if it is given in the option, you can go, otherwise you can leave it. Next, general characteristics of D block element. What are the characteristics? Let's check. So the elements of the periodic table in which the last electron fills up in the D block element, you can say D subshell, that is called D block elements. The D block elements are placed in the groups named third B2, you can say 1B and 2B. 1B and 2B is for that last one, we can say copper family and zinc family. Okay. Now in D block elements, the electron gets filled up in the D subshell of the penultimate shell. Not a big deal. D block elements lie between S and P block elements. We have already seen that. The general electronic configuration of these elements is n-1d, 1 to 10, and ns 0 to 2, where n is equals to 4 to 7. All of these elements are metals. Okay, not a big deal. Everyone, we know that. Next, out of all the D block elements, mercury is the only liquid elements we have to keep in mind. Next one. Now, general characteristics of F block elements. Now, let's talk about them. The last electron is going to be filled in the F subshell. Not a big deal. Next one. That F block elements are from atomic number 58 to 71. They are called as lanthanoids. They are called as lanthanoids. Okay, and 90 to 103 is nothing but actinides. Okay, now the lanthanoid occur in the nature low abundance, and therefore these are called rare earth elements. Now, what are the rare earth elements? Rare earth elements, they are nothing but, you can just take scandium, yttrium plus all the lanthanides. All the lanthanides with scandium and yttrium is called rare earth element. Please keep in mind, because they are very less in amount in nature. Next, the elements from atomic number 57 to 70 are called lanthanides, while 90 to 103 are called actinides because they come after actinide, because they come after lanthanum. Now, all the actinide elements are radioactive, a very important point. All the elements after atomic number 92 are you can say transuranic substance. After uranium, they are called transuranic. But in lanthanides, please keep in mind one thing. In lanthanides, promethium, that is PM, is radioactive. Radioactive. This question may be asked. Next. The elements Z equals to 114 has been discovered recently. It will belong to which of the following family or group in the electronic configuration? As I have already told you, just think again for how you can think just opposite way. We know that 118 that is given as organosine, that is what 118 is what? Noble gas. It is what? Noble gas. And before noble gas comes halogen. Before that oxygen family, or you can say chalcogens. Okay. Now, so what we can say, this is oxygen family, and then comes nitrogen family, then comes carbon family. So can we see 118 के इससे पहले क्या आएगा? 17, 116, 115, and there will be 114. So what we can say, this will belong to carbon family. So what we can say, of course, carbon family is the correct option. After radon is the, just you can think about the what is the last, or you can say previous. We have noble gas, that is radon, that is 86. After that, we can see that after radon, you will go for the next shell. Next cell is what? 7 cell. So 7s2. Then we'll go for the 6d. And 6d में कितने electron? 10. And then you will go for the 5f. 5f में कितने electron? 14. And then you will come to the p. And for carbon family, what is the formula? ns2, np2. So therefore, the electron will be how much? 7p2. Not a big deal. You can easily do such kind of question. The last elements of the p block in 6th period is represented by the outermost electronic configuration. Can you think about the 6th period? 6th period is there for the, means the n value should be 6. So here it is 7, 7 wrong. 7 ki to baat hi chhod do, because it is 6th period. So maximum value of n will be 6 only. So 6s2, 6p6. So of course, because here it is going to be completed. So what we can say, yes, it is the in the 6th period, because last element of any period is going to be what? Of course, ideal gas, and ideal gas has the ns2, np6, or you can say not ideal gas, sorry, noble gas, noble gas. Not a big deal. I hope you all see that. Next, which of the following elements do not belong to the family indicated? Copper, kinase metal, yes, it is correct. Barium, alkaline earth metal, for sure, because beryllium family ka hi last, this one barium. Zinc, alkaline earth metal, no, we all know that it is only from the d block element. Xc is noble gas, yes. All an atom has electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, and these things. Okay, you will place it in which group? Acha, where the last final electron is being added. Can you see? First of all, once you do 3p6 is nothing but you have completed argon. After argon 18, you fill the electron in 4s2. So then 2 electrons went there, and at last the electron will be filled in the D, because we know that how to fill the electrons from the, yes or no, n plus L rule. Arey haan bhai, yes. Now what we can say, so it is what? So it is 3D, D. So therefore, okay. Acha, in D also we all can see that it is 3. What is the n key value? N key value is 4. Anyways, it is, acha, it is asking for, it is such an easy, right? So so it is asking for which group you will put it into. Now we know that for S it is going to be 1A, then it is going to be, or you can say 1, then 2, it belongs to S, and then comes D, yes or no? And D ke liye what we just give these names, you can see 3, then 4, then 5, then 6. We all know that how many of the electron are being filled? 3. So after 1, 2, 3, 4, 5, how many of the D electrons are there? 1, 2, 3. So of course it is going to be, so which group it is there? 5th group. So option A is the correct option. Any dikkat? I think it is very easy. The elements with atomic number 118 will be, we already have seen, it is noble gas. Next, screening effect and shielding effect. What is screening or shielding effect? Always think about it. I know that you have already known all these things, but still again consider how an atom, you can see, you can consider an element as the atom as the, you can see a sphere. Inside the sphere there is going to be nucleus, and there is going to be the last element, or not last electron, that is going, you can say that it is the valence electron. This nucleus wants to attract the last electron, but because of the presence of the electron in between, all these electrons in between, they will repel the final, or you can say last electron, or valence electron. So what will happen? The attraction that this nucleus wants to put in this last electron, it could not be possibly reach, or this much of attraction it cannot give. So what will happen? There will be whatever, consider it has the atomic number Z. So whatever is the number of proton is there, let's say Z. So it will try to attract with the Z, but it cannot, or it will not be able to attract the last electron by the Z force, but it will be giving, due to the presence of the electron in between, let's say Z minus some factor. It is decreased due to the presence of these, you can say, screening electrons. So, or shielding electrons, because these electrons are shielding the attraction of the nucleus on the final electron. That's why the in between electrons are called shielding electrons. Now, that's why what happens, the final electron or the last electron does not feel that much of the pull, or you can say attraction towards the nucleus, and whatever is the amount of pull it is feeling, or the charge it is feeling, it is called Z effective, or effective nuclear charge. So it is the, what we can say, effective nuclear charge. So what is this? Though there is a Slater's rule, we find the Z effective by Z minus sigma, but because of the lack of time, and as well as we know that it is not as much important, we have not seen many questions from last many years, so that's why we are not discussing this right now. But still, understand what is the whole point, that because Z is trying to attract this last, you can say, test electron, but it is not able to attract by the whole charge. The reason being that all these inner electrons, because they are repelling the final electron, the test electron, due to this inter-electronic repulsion, this is being, pushed outside, or it cannot be pulled inside by that much of force. That's why, and whatever is the force, whatever is the, in between these electrons are there, they are screening electrons. They are screening or shielding electrons, because they are shielding electrons. And let's say due to these shielding, there is some decrement in the effective nuclear charge, that is sigma, that is screening constant, and that is why we have written this sigma, that is screening or shielding constant. Z is what? It is the Z, that is, we know that, atomic number. Now, periodic variation. What is the periodic variation of Z effective? Once we go from left to right, we just find out Z minus sigma. With this, we just find out, try to find out, and we see that once we go from left to right, the Z effective keeps on increasing by 0.65 values. Now it is in the S and P blocks, but once we go in the D blocks, D block element, in the transition elements, it increases by 1. But that is not the point. The point is that when we go from left to right in a period, Z effective always increases, or we can say the pull of the electron towards the nucleus increases. Next, from top to bottom in a group, Z effective remains constant. What we can say, from top to bottom, initially there between second and third period, you will see that there is increment, and then what will happen? And then you will see that it will become constant. Yes or no? Not a big deal. So basically, top to bottom it is constant, while left to right it increases. Next, in a given shell, the order of screening effect is, now in a shell what will happen? Screening effect, always remember, something that is more closer to the nucleus, that can screen the outer electron more easily. Yes or no? Consider you want to approach someone, who can stop you from approaching that person? Who is more closer to that person? Yes or no? So those subshells which are closer to nucleus, they have the higher screening effect. So S, because S has higher penetration power than P, than D, than F. S is more than, P is more than. So penetration power, you can see penetration power or penetration tendency of S is more than, P is more than, D is more than F. So what we can say? So therefore, the screening effect of S will be more than, P is more than, D is more than F. Yes or no? I hope you understand it. Now, the periodic property, that is atomic size. We have come to the periodic properties. So how many of the periodic properties are there for you to study? Atomic size, and then we are going to study about the second one, that is ionization enthalpy. Third one is electron gain enthalpy. Electron gain enthalpy ka bhai hai, that is electron affinity. We will study both of them, and then at last electronegativity. So these four things are there in your syllabus, and they are going to be very important, and their applications are very important. We are going to solve a lot many questions. So we will complete this theory very fast and go with the question better. Okay, now, so what are the different types of atomic sizes are there? Because we cannot find the, because of the Heisenberg's uncertainty principle, we do not know that where is the final, or you can say last electron of an atom. So we can never see that how big and how small an atom is. because you never know that where is the final, or you can say nth cell is there, right? So in such case, what we can say, we can never find the atomic radius of any isolated atom. So in such case, what we have to do, we have to find out in its bonded form. So in this bonded form, on the basis of type of bond, we find out there are three types of covalent radius are there. So one is covalent radius, metallic radius, and then van der Waals radius. Now covalent radius, whenever there is any substance or any element that is in the covalently bonded. So how do we find out this covalent radius? We just find out what is the internuclear distance, what is the distance between the two nucleus, and then whatever is that, we just divide by 2. So half of that distance is known as the covalent radii. Can we see that? This is the distance, that is internuclear distance, and R covalent equals to d by 2. D by 2. Not a big deal. I hope you all understand it. Now next comes the metallic radius. Metallic radius, again same thing. When there are metals are there in the metallic, or you can say metallic bonding. Now whatever is the distance between these two nucleus, now if you just divide that distance by 2, you will get the R metallics, that is metallic radius, that is d by 2. And next comes the van der Waals radius. What is van der Waals radius? Just think again that there are many of the elements which cannot form any bond by their nature, because we know that, like all the noble gases, yes. So these noble gases do not make any bond. Now in such case, how do you find out there? Because they cannot form the covalent bond, they do not have the metallic bond. So what we do, first of all, we make them in the solid form, and once we solidify that, so whatever is the distance between the two different, or you can say consecutive elements, or two consecutive atoms are there, whatever is the distance between their nucleus will be there, just divide by again half, you will get the van der Waals radius. Okay, so they are in the kind of force that is you can say intermolecular force, that is RW, that is van der Waals radius. Now understand one thing always, that R covalent is smaller than R metallic is smaller than R van der Waals. So, or you can say R van der Waals is more than R metallic is more than R covalent. Question comes from here, very important. Next, here van der Waals radius, half of the internuclear. Yeah, I think you all know that, not a big deal. I hope you all, we have already studied about it. Now ionization enthalpy. What is ionization enthalpy? Whenever is there, whatever is the most loosely electron present in any atom, what we also call this, we also call it the valence electron. So whatever is the amount of energy you are giving to remove that electron, you can say uproot that electron, that will be called, what you will call it? You will call it ionization energy. But when that atom is isolated form, if there is any gaseous isolated atom is there, if you remove the most loosely electron out of there, so this energy that you are giving to do that, it is called ionization energy. Now because electron is negatively charged and nucleus is positively charged, they will have an attraction, and if they have attraction, so you are trying to, so to remove that electron, you have to give the energy from outside. So if you are giving the electron from outside, this whole process is endothermic or exothermic, it is endothermic. So therefore always remember that ionization enthalpy is always positive, never it is negative. Please keep in mind. Now if you are removing first electron, it will be called first ionization energy, second, third electron, third ionization energy, yes or no, not a big deal. So very important thing to please keep in mind, that if you keep on removing the energy, electrons, it will become, so IE1 is less than IE2 is less than IE3, and there is no, you can say, no exception to this, always following this. Okay, okay, now we are going to the next thing here. So the ionization energy, we have already seen that. Now one thing you always have to keep in mind, that there is, when there is increment in ionization energy, so if the electron you are removing from the outermost shell, or you can say from the valence shell, so the difference between the ionization energy is less. But as you keep on removing the electron, and as you reach to the electron that is from the penultimate shell, so what will happen? The difference between the ionization energy will become very much. What we can say, just like I will give you example, you take magnesium. If you remove one electron from magnesium, how much of magnesium has, you can see 1s2, 2s2, 2p6, and then what we can say directly after, neon. Okay, or right, 1s2, 2s2, 2p6, and it will be 3s2. So how many of the electrons are there in outermost shell? There are 2. So first electron you can remove, it will be called IE1, and then second electron if you remove, what will happen? It will be called IE2. If you remove one more electron, it will become Mg plus 2. By here, so you are just removing electron from the outermost shell, so not an issue. That IE1, or you can say IE2, is greater than IE1. So here you can just see this relation. But once you want to remove one more electron out of it, that is IE3. So amount of energy that you will give, IE3. Now you are trying to remove the electron from penultimate shell. You were removing earlier from ultimate, or you can say outermost shell. Now you are trying to remove from the penultimate shell. So that electron is even more closer to nucleus. If it is more closer to nucleus, it will have more attraction. If more attraction, you cannot remove it so easily. So there the amount of energy you have to give, it will be very large. So therefore, what we can say? So IE2, IE2 is more than IE2, but IE3 is very larger than IE2. The reason here being is, I hope you understand. Let's say if it is sodium, so first electron, so you can easily remove because it is 3s1, but second electron will be removed from the penultimate shell. So here the increment will be very high. If you talk about aluminium, the first 3 electron will be easily removable, or you can say there will be not a very large difference between the IE1, IE2, IE3, but once you go for the fourth electron, that is IE4, it will be a very large difference between IE3 and IE4. I hope you understand what is that main thing I want to tell you. Next we are going to talk about is electron gain enthalpy. Just think about if there is any isolated gaseous atom, if you are trying to give it the electron, so the amount of energy that it releases, that will be called electron gain enthalpy. Generally it is negative, but is it always negative? No. So in such case, or what we can say, the amount of energy released or absorbed in the process of taking one electron by an isolated gaseous atom is called, what we can say, electron gain enthalpy. Generally it is negative, but not always. So where it is not negative, please remember, for nitrogen, what we can say, generally acceptance or adding of electron is an exothermic process. Exothermic process means delta H is going to be negative. So delta H is going to be negative, but delta H Eg is positive for nitrogen, then beryllium family, and for noble gases, Please keep in mind, very important. Why nitrogen? Because it has half filled p orbital, half filled 2p3 orbital. Can you see? Beryllium family, because they have the ns2. ns2 is what we can say, it is also half filled, or sorry, it is fully filled. It is fully filled, you can say ns2, because s or subshell is completely filled. And what about the noble gases? Because they have octet complete, and not just octet complete, but also we know that it is not just about the octet completion of the octet, because it is a very stable electronic configuration, so they do not really want to take any electron into it. Okay, so understand it. Now we are going to talk about next few things. There are many questions that is coming here. We'll talk about the trend also. Okay, let's talk about the trend. Yes, we have not talked about the trend from ionization enthalpy only. So what is the ionization energy? What is the trend? Once we go from left to right, the Z effective increases. As the Z effective increases, the electron pulling of the electron will be very tough, because their pull on the final electron will be more. So therefore, as we go from left to right, electron enthalpy, left to right, what we can say, increases. But once we go from top to bottom, it decreases. Yes or no? Not a big deal. I hope you all understand it. Next we have come to this electron gain enthalpy. So here left to right, generally it should, electron gain enthalpy negative, in the negative sign it should be increased. Okay, increased in negative sign. And once you go from top to bottom, so it should decrease in, you can say decrease, but in the negative sign. If it, okay, I hope you understand it. But there are few exceptions are there. What are these exceptions? Exceptions in the second and third period. In second and third period, what we see that if you talk about lithium and sodium, so lithium is, we expect that lithium should be more, but what happens? Sodium is more. Do not talk about beryllium family because it is positive. Uski baat chodo. Next we talk about the boron. Boron is less than aluminium. If you talk about next, carbon is less than silicon. Nitrogen is less than phosphorus. Then you talk about what we say, oxygen is less than sulfur. Fluorine is less than chlorine. So these are very important points you have to keep in mind. But this same physical property, we also measure it in some other way, or we also call it another name, that is electron affinity. More the affinity for any electron, for the electrons will be there, the more the electron affinity will be there. So we sometimes we give this electron affinity EA equals to negative of delta H Eg. But here delta H Eg is just with the negative sign. So because delta H Eg deals with the sign, that you can say energy difference or energy transition. But electron affinity talks about the how much of affinity of any element towards the electron is there. So we cannot make it negative. That's why we call negative of negative, just to make it negative of negative. So that's why electron affinity, more the positive, the more electron affinity will be there, the more the attraction for the electron will be there. So therefore we have kept it negative of delta H Eg. You have to just keep in mind. Okay, next we are going towards electronegativity. Electronegativity is one of the, it is, students generally do not really much understand it now, but still what we are just going to talk about on surface, and then we are going to talk, or you can say solve more questions. Now, a qualitative measure of the ability of an atom, whatever the things we have studied by now, it is all for the isolated atom. But now we are going to talk about a system of atom that is bonded. Okay, now, so a quantitative measure of ability of an atom to chemically compound to attract the shared pair electron in to itself is called electronegativity. So electronegativity is the tendency of any atom to pull the electron which is bonded already with some other element. Okay, so shared, जो वो आपके shared pair of electron है, उनको खींचने का जो tendency है, that is called, you can say, electronegativity. Now, in this electronegativity, do we have any way to measure it? No. It is because it is a relative term. So basically, there is no way of finding, or you can say measuring it. So we have got lot many scales on it for electronegativity. One of the scale is very important, that is Pauling scale. It becomes very important. What it says, there are applications of Pauling scale. It just defined as considering hydrogen has the electronegativity how much, 2.1. On the basis of it, all the other elements are given their electronegativity. The most electronegative element that we have got is fluorine, and we can see that because in any of the bonded atom, what we can say, fluorine will not be, you can say, fluorine will be pulling the electron by the maximum extent. So therefore what we can say, that electronegativity of the fluorine is maximum, that is how much, 4. So if you talk about what are these values, please, I will suggest you please go through any of the book in NCERT also. You can just see all these values, go through it. In the second period, whatever is there, you have to at least keep in mind that fluorine is 4, oxygen 3.5. So you just have to decrease 0.5, 0.5, 0.5, and you have to just keep up to lithium. That you will get what? How much? 1. Okay. So let's go to the next part and see what are the applications. Just something that there is very important, that is application of electronegativity. Always keep in mind what are these applications. If charge on central atom increases, so electronegativity also increases. If percentage S character increases, then electronegativity also increases. So what we can say, we can never say that one atom or one element has always a fixed electronegativity or fixed electronegativity value. No, depending on which kind of bond it is forming and what kind of charge there is on that atom, so it will have the different electronegativity. So please keep in mind, so electronegativity is not a fixed value. No. Now, so it's just a relative value. Please keep in mind, this is just a relative value. Okay. Next, if you talk about that, what else just makes it, that if you can see, if you go from left to right, electronegativity also increases in any period. If you go from top to bottom, electronegativity decreases. If Z effective increases, then what we can say, then also electronegativity increases. These are the things that you have to keep in mind. Now in the application, what we can say, let's say there is any bond A, then B, then C. If we put it into water, which bond will be formed? whichever will be having more, you can say, polarity, or you can say electronegativity difference, the more the electronegative, consider it as x1, consider it as x2, consider it as x3. So if x1 minus x2 is more than, I'm taking mod, is more than x2 minus x3, what we can say? So x1 and x2 is more polar bond, so which bond will be broken? It will be broken like this. Consider A has, you can say, less electronegativity, B has more electronegativity. How it will be formed? It will be, you can say, sorry, it can be broken as A plus and BC minus. I hope you understand it, how it is all working. But if this electronegativity difference was less and this was more, then which bond will be broken? BC bond will be. I hope you understand it. And then which will be given negative? Whichever has higher electronegativity, that will be given negative. Whichever has lower electronegativity, that will be given positive. It's a very simple thing you have to keep in mind. Now there are many things others, like which of the molecules will be covalent, which of them will be ionic. So it all will be there on the, again, if the electronegativity difference is 1.7 or more, it will be predominantly ionic in nature. But if it is less than that, it will be polar in nature. If it is 0, electronegativity difference is 0, it will be non-polar covalent. If it is more than 0 but less than 1.7, then it will be polar covalent. If it is more than 1.7, it will be ionic, predominantly ionic. Okay, so these things I hope you all know that, right? So let's directly go to the question solving, and before that, it is the short overview of all the different periodic properties, like electron gain enthalpy increases from left to right, ionization enthalpy increases from left to right, because both of them are directly proportional to Z effective. Yes or no? There are many things yet we are going to see next time in the question solving. Electron gain enthalpy here increases from bottom to top, or you can say decreases from top to bottom. So where there is, you can say head of the arrow, means it is increasing. I hope it is all clear. You can go through it, not a big deal. Okay, next. Now the correct order of size would be, what is the size? Means it is talking about radius. Nickel, platinum, palladium and platinum. Of course we see that, because nickel is nothing but it is nickel, platinum and palladium. They are from the 10th, you can say 10th group number. What we can say? 10. Yes or no? So it is nickel, because it is from the 4th period, and it is from the 5th period, it is from the 6th period. Because as the period increases, what will happen? So n value increases. So as the n value increases, the electron, the farthest electron will be more farther, so that their size will be more. So of course A is the correct option, not a big deal, right? Next is among oxygen, carbon, fluorine, chlorine, bromine, correct order of increasing atomic radii. Just see that. If you talk about atomic size from left to right, what happens? Size decreases. So if you talk about oxygen, carbon, fluorine, all of them are from second period. So what we can say, the carbon will be largest, and then it will be oxygen, and then it will be fluorine. But we know that as we go to chlorine, because it is from the 3rd period, it is from the 4th period. So as the period increases, always remember, as we grow from left to right, what we see generally Z effective. But as we go from top to bottom, what we see generally, we see the change in shell. That is the main reason for any periodic changes. So as the cell changes, the difference in size becomes bigger. So that change is going to be even bigger. So कार्बन से भी ज्यादा बड़ा कौन होगा? क्लोरीन. एंड क्लोरीन से भी ज्यादा कौन होगा? ब्रोमीन. सो यू कैन सी दैट विच इज गोइंग टू बी करेक्ट. ब्रोमीन, क्लोरीन, नो, ब्रोमीन, क्लोरीन और कार्बन, ऑक्सीजन. ऑफ कोर्स यू कैन सी दैट. नेक्स्ट, अरेंज द एलिमेंट्स इन इंक्रीजिंग ऑर्डर ऑफ देयर एटॉमिक रेडियस. सोडियम, रुबिडियम. अच्छा, कैन यू सी दैट सोडियम, पोटेशियम, रुबिडियम, all of them are from the, you can say, alkali metals. So what we can see, as we go down, the size will be bigger. So sodium will be less than, potassium will be less than rubidium. I hope you all understand. The reason is because sodium is from 3rd period, it is 4th period, it is from 5th period. But if you talk about sodium and magnesium, because magnesium is left, you can say left to, you are going from left to right, so magnesium is right to sodium. What we can say, magnesium will have the smaller size. So what we can say, magnesium is smallest. So magnesium, sodium, potassium, rubidium. Okay, can you see that? Not a big deal. Which group of the atom have nearly same atomic radius? Nearly same atomic radius. So sodium, potassium, rubidium, cesium, no. Lithium, beryllium, boron, carbon, no. FeCO, Ni, yes. In FeCO and Ni, what we see कि यहाँ पे nuclear charge, that is, you can say, it is increasing, so therefore the size decreases, but at the same time, due to the poor shielding of D, you can see D, the same time it also increases. So there is a tussle, or you can say competition between both of them. and in FeCO both of them, you know, manage to be almost close to each other. So that's why their size becomes almost same or remains almost same. Ionic radii are inversely proportional to effective nuclear charge. Yes, yes, of course it is correct. So what we can say, R is inversely proportional to Z effective. The more the Z effective will be there, the more the pull on the electrons will be there, the smaller their size will become. Not a big deal. Next, what is the time? Next is the ions O minus 2, F minus 1, Na plus, Mg plus 2 aluminum are isoelectron. Their ionic radii. Always keep in mind, in isoelectronic species, so size is directly proportional to negative charge, or you can say size is inversely proportional to number of protons. Okay, not a big deal. You can see that. So which is having maximum negative charge? This. So their size will be. Can you see that how many number of electrons are there? You can check in all of them. There are how many electrons? 10. So their size will be, maximum will be for O minus 2, and then it will be F minus, and then it will be Na. You can see that. So minimum will be for aluminum plus 3, maximum will be for O minus 2. So we have to write the ions, this are isoelectron, their atomic radii. A significant increase from O minus 2, no, oxide 2, it will decrease. Significant decrease from O minus, yes, for sure. Option B is the correct option. Next, we are going to talk about the correct order of atomic radii in group 13 element is. See, always remember, there are few things that we have to keep in mind. Because of bad, or you can say poor shielding of D and F, because S and P shield very well, because they are penetrating the nucleus very well, so they are close to nucleus, so they can shield the outer electron better. But D and F do have very bad screening effect or screening power. So therefore, what they can say, they do not screen the outer electron so well. So therefore, there is a effect that is called scandiide contraction. That is nothing but scandium ki family is nothing but from scandium to zinc. It is all what? Scandiide family. So what we can say, due to the presence of D in between, that S, that is nothing but 3s and 3p, 4s and 4p, there is 3D whole scandiide family is there. So due to this scandiide family, so the Z effective increases. Why Z effective increases? Because their poor shielding is very poor. As the shielding becomes very poor, what will happen? See, consider it like that. We can see that in the third, after fourth period, if we talk about fourth period, so what we see? Potassium, calcium, and then there is going to be all that D, all that scandium to zinc is there, and then there is gallium, and upside there is what? Sodium, magnesium, and all of them are there. And there is what? There is aluminum, but there is no D block elements are there in the third period. Yes or no? In third period, there is no D block element. So once this scandium family, or you can say D subshell is there, so D subshell ke electrons, they have poor shielding. And due to this poor shielding, what happens? Z effective increases. So therefore, because sigma decreases, so therefore Z effective increases. As the Z effective increases, the electrons of the outer electrons get very much pulled towards the nucleus. So their size becomes less. That's why gallium size becomes very less, and so less that it becomes less than almost aluminum, or almost become equal to aluminum. Aluminum is even more only. So what we can say? So there is a change here, and due to what? Scandiide contraction. So after boron, it is not aluminum. What we expect, that as we go from top to bottom, it should increase only. But there is a change, that is gallium becomes less than aluminum. So what we can say? Boron, gallium, aluminum, not thallium, indium thallium. So D is the correct option. See, it is a very good. Thallium, indium is given. Many of the students will take it just by seeing gallium and aluminum. You have to see that thallium and indium also. Okay, next. So the species argon, K plus, all of them are what? Isoelectronic. You can see where the maximum charge is there, so it will be smallest. Where the minimum charge is there, argon, so it will be largest. So what we can say? Argon. So option A, very easy, right? Next. Which of the following order ionic is correctly? I hope you all can see that H minus is more than H plus is more than H. No, because it is what? H plus should be less than H. So यहाँ पे wrong हो गया. Next, Na plus less than F minus is less than. Yes, of course it is. We can see that here positive 1, negative 1, here negative 2. More the negative, more the size. Next, identify the wrong statement in the following. Atomic radius of the element decreases as one moves from left to right in the second period of the. Yes, of course it is correct. So what it is asking? It's a wrong statement, but it is true. Now, among the isoelectronic species, smaller positive charge on the carbon smaller is the ionic radius. Yes, whatever is the element doesn't matter. If the, you can say, smaller positive charge on the carbon, smaller is the ionic radii. No, bigger the positive charge is there, the smaller is the ionic radii. Okay, amongst the isoelectronic species, smaller the positive charge or not, it should not be carbon. What is that? On the carbon, on the smaller is the ionic radii. Okay, amongst the isoelectronic species, greater the negative charge on the anion. Acha, it is cation. Okay, cation. Cation. It wants to say cation. Okay. So amongst the isoelectronic species, greater the negative charge on the anion, larger the is the, yes. यहाँ पे smaller the positive charge, the smaller the ionic. No, it is false. It is false. Smaller, the larger the positive charge, smaller the ionic radius. It is correct. So it is false only. So B should be. Atomic radius of the element increases as one moves from first group to in the down in the first group in the periodic table. Are it is also, acha, it is true, na? It is correct. So which one is correct? So because it is false, so it is correct. Next, identify the correct order of size of the following. Again, same thing. Isoelectronic species, maximum, it will be smallest, it will be largest. Next, which of the following is correct order of size of iodine species? Once minus is more, same kind of question is coming, right? So always remember A minus N is more than A is more than A plus N. Why it is all happening? Because of Z effective increases. Here to here, Z effective is increasing. Why? Because electron is being removed and because the protons are same only. So more protons are pulling less number of electrons. They will pull those electrons very much. So therefore their size will become very small. Not a big deal. So I minus I plus. Next is among the elements calcium, magnesium, phosphorus, chlorine, the order of increasing atomic radii. Again, you can see that you all can see from left to right, size decreases. So you can just do that, not a big deal. Okay, please. Okay, no, sorry. But here it is talking about calcium also. Okay, so calcium is anyways going to be more. Okay, so magnesium, so calcium is going to maximum. So option, this one is correct option. So among the following, why this is? Because we know that calcium is from the 4th period, while all others were from the 3rd period. Okay, among the following elements whose electronic configuration is given below, which one of the highest ionization energy is? Okay, highest ionization energy. Can you see it is what? It is nitrogen. It is what? Oxygen. It is what? It is what? Neon, argon. Just a minute. Achha, 3. Phosphorus. It is what? Sulfur. It is what? 4p2. 3d10 4s2 4p2. Okay, it is what? It is from the 4s2 4p2. So matlab silicon, germanium. Okay, let's talk about it. Having highest ionization energy. For highest ionization energy, what we have to see? Here organ. Organ is going to be anyways because it is noble gas, so nothing is going to be close to it. It is going to have highest ionization energy. Next, the energy needed to remove one electron from unipositive ion is abbreviated as, if you have already M2 M plus 1, so one ionization energy is already used. So from here, if you remove one electron, what is called IE2, that is ionization energy 2, it will become M plus 2. So IE2. So there is second ionization potential or second ionization energy. The second ionization potential in, now we have come to the question of ionization potential. Can you see that? In electrons, electron volts of oxygen and fluorine atoms are respectively. It is talking about the second ionization potential. Oxygen and fluorine. What is oxygen? 3s2, sorry, 2s2, 2p, 2p4. But what about this? 2s2, 2p5. Can you see? First electron, if you remove one first electron, it will become, so it will become, you can see 2s2, 2p, 2p3. So it has become what? Half filled. If it has become half filled, so second ionization potential, second IP will be very high. Very high. Why? Because it is half filled. It does not, because it is more stable, so it will not really try to remove it. So it will be high value. It will be higher. While here, if you see the first one, that is IE1. Of course, here IE1 is going to be, if it is IE1 for oxygen and IE2 for oxygen, fluorine, so IE1 for fluorine is more. But once you go for IE2, so if you go for 2s2, 2p, 4. It is not half filled, so you can easily remove the electron. So IE 2 here is going to be high. So sorry, not so high, or you can say lesser. You can say it is lesser. The reason for here it is half filled is the main reason. So oxygen should have higher while the fluorine should have lower. So higher, lower, higher, lower. No, high, lower, higher, higher, equal. So C is the correct option. Very, it's a good question. Just use the mind and you can do that. In which of the following options the order of arrangement does not agree with the variation of property indicated against it? Aluminium, so it is what? Increasing ionic size. Of course it is what? It is correct. Acha, it is telling not agree. So but it is true. It is true. So here increasing first ionization enthalpy. Can you see nitrogen and oxygen? Always remember कि ionization enthalpy, always remember कि here beryllium family and nitrogen family, they interchange with their next elements. Why so? Because beryllium family also have the fully filled ns2 orbital or ns2 orbital, while if we talk about the nitrogen, they have np3. So what is that? np3 is half filled. So they are more, stable electronic configuration. So removing electron becomes more tougher. So here what happens? Please remember, boron is less, yes. Then what happens? Carbon, and then what happens? Oxygen, and then what happens? Nitrogen comes. Here there is change. So no, this is what? This is false. So option B is the correct one. Next, we are going to talk about element that has the greatest tendency to lose an electron is. Electron कौन lose करेगा? जो कि that, yes, we can see that. Fluorine, francium, sulfur, no. It is going to be francium. Because always remember, once we go from left to right, what happens? The ionization enthalpy decreases. And we know that francium belongs to the 1s, we can say that 1a, or alkali metal. Alkali metals have the weak, you can say, smallest ionization enthalpy. That too, as we go from down, up, top to down, it even decreases. So in such case, what we can say? That francium is going to be, yes, the correct option. Amongst the following, the incorrect order is, acha, IE1 of aluminium is less than IE1 of magnesium. We all know that the magnesium has higher IE1 than aluminium. The reason is, here it is 1s2, 3s2, that is fully filled. While here it is what? 3p1. 3p1 electron is easily removed than 3s2. So it is correct. Acha, correct hai to incorrect पूछा है. Sodium and magnesium के लिए IE1 of sodium is less than, of course it is also correct. Next, magnesium is more than IE2 of Na. Acha, it is talking about IE2. Let's talk about IE2. So if you talk about sodium, it is going to be 3s2, 3s1. While if you talk about magnesium, 3s2. So if you remove one electron from here, so it is from the outer orbit, but once we go for the second electron, it will be in the second 2p6. So it will be what? Inner. Again, same thing that I have told you now. If you are trying to remove the electron from the penultimate shell, the energy required will be very high. So for sure, here sodium should be more. So it is wrong. So therefore it is correct option. Next, we are going to talk about, for the process this to this to this, energy is released. Energy is from here to here, potassium, it is taking electron. So if anything positive is there, it will, of course, it will take the electron easily. So it is energy delta H is negative. Here delta H is negative. Here to here, gas to solid. Solid to gas, we know that you have to give the heat to make solid to gas. So if solid to gas is there, you have to take the heat. So again here delta H will be negative, not a big deal. Okay. So energy is released in both the cases. Next, the elements which has highest second ionization energy, you can just see that it will be sodium. The reason being is that second electron from penultimate shell, penultimate shell, not a big deal, easy one. Next, the third ionization energy is maximum for, I think it is magnesium. Acha, both of them has, it has what? 3s2, it has what? 2s2. So which is the closer electron? Can you see? The two electrons are okay, but third electron from penultimate shell, penultimate shell. If it is from penultimate shell, it will take a lot of energy, but beryllium is smaller, so it is closer. If it is closer, the removal of electron will be tough. So option D will be the correct option. Assertion, the first ionization energy of beryllium is greater than that of boron. Yes, the reason is fully filled. 2p orbital has lower in energy than 2s. Yes, of course, it is also one of the reason, because the beryllium has 2s2, while boron has, it is 2p1. So it is of higher energy, it is of lower energy. So if you try to remove the electron from here, it will be tougher. While if you try to remove an electron, it will be easier. Anyways, P has the lesser, you can see, what to say. So okay, assertion is correct, reason is also correct, okay, but reason is not the correct explanation for the acha, or it is the correct explanation. I think we can go with the not correct, because the better option will be beryllium has the fully filled 2s orbit, and because S has more penetration power, not about the energy, okay. And energy also goes like that. If the energy penetration power is more, energy becomes less. So option A can go. We can go with that also. Next, the process requiring the absorption of energy is F to F minus. No, because here the energy is going to be released, because electron enthalpy, electron delta HEG is negative. Okay, Cl2 here also negative, delta HEG. यहाँ पर देखो oxygen से O minus पे आए, it is negative. Once we try to give one more electron, because oxygen has already, you know, oxygen is small atom, you have already given one electron, now one more electron you want to give, so that one already electron tries to push the electron, because it is already negatively charged. One more electron if you try to give, no, it is not going to take. So delta HEG2 is going to be positive, it is going to be positive. So you have to give the energy from outside to take one more electron, okay. So of course option C is going to be the correct one. Next, relation between the electron gain enthalpy and electron affinity is negative. We have already seen that. Next, highest electron affinity is associated with the configuration. Acha, can you see what is this? It is what? 2s2 boron. It is what? Nitrogen. It is what? Carbon. It is what? 2s2. That is beryllium. So who will easily take that electron? Of course not nitrogen. Carbon, boron, which one is going to take? Of course carbon is going to take this. Why nitrogen not? The reason is because nitrogen, we already know that इसके लिए delta HEG is positive, while for all of them it is going to be, of course इसके लिए भी positive, but the point is this carbon is going to be delta HEG negative maximum, delta HEG maximum negative, so it will easily attract the electron. Next, which of the following case is endothermic? Chlorine to chloride, no. P to P minus, no. N to N minus, yes. Option C. We have already seen that delta HEG positive for nitrogen, beryllium family and noble gases. Yes or no? Next. The electron affinity values for the halogen shows the following trend. We all know that electron gain enthalpy, electron affinity for chlorine is more than fluorine. The reason being fluorine is small in size while chlorine is bigger in size. So if the electron tries to come, of course, fluorine has these electron in that second shell. They have very less space. If you try to give one more electron, they repel it. While in chlorine there is a lot of space because it is third shell mein there is a more space. If one more electron wants to come, it can accommodate. So fluorine less than chlorine, then chlorine is more than, bromine is more than. Yes, that's correct. Now the formation of the oxide O-2 from oxygen atom requires first an exothermic, acha, because first electron is taken easily, so exothermic, then an endothermic step as shown below. Okay, this and this. Okay, thus the process, the overall process will be negative of 1 minus 141, but positive is very high. So overall delta H overall goes to be positive. Thus process formation of has unfavorable, even oxide is isoelectronic with the neon is due to the fact, though O-2 is neon ka electronic configuration, that is very stable, but still it is unfavorable, or you have to give the energy from outside to happen. So the reason is what? So electronic repulsion outweighs the stability of the whatever is stability gained due to achievement of the noble gas configuration. Not for the second period element, the correct increasing order of the first ionization enthalpy. I hope you all know that. Not a big deal. Lithium, जैसे आप नीचे आगे जाते हो, तो it always increases, but nitrogen and oxygen change and beryllium boron change. Now what we can say, lithium, boron, beryllium, carbon, oxygen, nitrogen. Option B is the correct option. Next, which of the following arrangements represents the correct order of the least negative to the most negative electron gain enthalpy for carbon, calcium, aluminum, and now least negative will be most negative is who is the most negative? I hope you all can see that in all of them the carbon is going to be, oxygen is going to be fluorine is also there, most negative for fluorine. But if you talk about the least negative, यार calcium की बात करो, calcium is going to be positive, so because it is from the beryllium family. So it is going to be basically, you can say least negative, least negative. So okay, calcium and option D is the correct. Calcium, aluminium, carbon, oxygen, fluorine. Okay, next. So which of the following electronegative electronic configuration an atom has the lowest ionization enthalpy? Lowest ionization enthalpy, जरा देखो इसको देखो, ये क्या है? 2p3, that is nitrogen. That is, it is what? 3s1, that is sodium. It is what? I hope you can see neon, and it is what? Fluorine. Least, that is of course whatever is the alkali metals will be there, they easily can remove the electron. They have metallic tendency. Next, which one of the following arrangement represents the correct order electron gain enthalpy with negative sign? यार देखो सबसे ज़्यादा क्लोरीन का ही होना है, तो क्लोरीन is more than fluorine is more than sulfur is more than oxygen. I have told you why this happens, because size is high, its size is more, while oxygen has the size small. While same thing, size is small, while chlorine has size more. That's why this happens. Next, which of the following elements has the maximum electron affinity? Chlorine, not a big deal. Next, the first ionization potential of beryllium and boron respectively are. Beryllium should have more because half fully filled, boron should be less. So more less, more less, more less, more less, more less, option D. It is equal, less more less, option D. Okay, easy hai. Which electronic configuration of an element abnormally high difference between the second and third, means the third electron is going to be taken from the penultimate shell, तभी तो abnormally difference बहुत ज़्यादा होता है. I have already explained that. Next, can you see यहाँ पर तो बस एक ही है. No, only one electron will be from the external or outermost. Second will be from penultimate. No, here second ionization enthalpy will be very much. So 3s2, if you can see, हाँ 3s2 of course. So यहाँ पर third electron from penultimate shell, penultimate shell. So option D will be the correct one. Next, which will have the maximum value of electron affinity OX, OI, OZ? अच्छा ठीक है, जरा सोचो, O per 0, O charge -2. So where it can easily take electron? Of course, because it is already having one negative, it is already having two negative. They will never take. This will take, because here delta H Eg will be negative. So of course here, so OX. So it is for OX, option A. In which of the following options the order of arrangement does not agree with the variation of the property? चलिए, IBrClF increasing electron gain enthalpy. No, it is correct. So A is the correct one. Not a big deal. Next, which of the following arrangement does not give the correct picture of the trends in the indicated? Bond dissociation energy. Fluorine is more than, no. Please remember, it is what? It is chlorine more than bromine, more than fluorine, more than iodine. So option A is the incorrect only. So it is correct. So it is asking for correct picture. Okay, not incorrect. So fluorine is more than chlorine. Electronegativity, yes. Option B is the correct one. Okay, not a big deal. Which of the following order is wrong? Acidic character. Acidic character, as we go from top to down, top to bottom, the hydrides acidic character decreases. You can say, so NH3, PS3, or here SH3. They can, sorry, what I told. So as they can easily give the HIN, so because this bond is weaker, so acidic character, of course it is correct. So lithium, beryllium, boron, carbon, first ionization potential, no, wrong. So option D, because here boron and beryllium should change their space. Next, arrange in the increasing basicity. NO2, KO2, K2O, and NO2 is acidic. K2O is basic. Zinc oxide is amphoteric. Please remember all the amphoteric oxides, very important. So therefore, increasing basicity. So NO2 should be minimum, and then maximum should be K2O. The correct order of acidic strength is, now, of course, as we go from left to right, as we go from left to right, oxide acidic character increases. So can we see here phosphorus, sulfur, no, it is wrong, because chlorine, Cl2O7 should be maximum. CO2, N2O5, NO, no, wrong, because CO2 cannot be more than N2O5. Na2O is more than, MgO is more than 8. What is acidic strength? Na? No, basic strength. K2O is more than K. So what is that? Acha, it is asking for correct only, na? So Cl2O7 is more than SO. Of course, oxide from of course. So option A is the only correct option. Okay. Among the following oxides, which one has the maximum basic? So it is what? Zinc oxide is M4. It is basic. It is amphoteric. It is acidic. So most basic is magnesium oxide. So next one, elements of which of the following group will form anions most readily? Okay, so I think we all know that halogens. Next is going to be match the oxide given in the property. Na2O basic B. So 1 ka B. Al2O3 that is you can see it is amphoteric D. N2O is neutral A. Cl2O7 acidic बहुत ज़्यादा C. So 1 का B, 1 का B, 2 का D, 3 का A, 4 का. Option A is the correct option. That is all from my side, class. Today's whatever we have questions discussed, it is very important. So please go through it. And one more suggestion from my side, please read all the atomic and physical properties from P block elements from 13 to 18, all very important. And all the D block elements, their graphs are there, whatever the color codes are there, please go through it, very important. Because I'm not going to talk about the P block elements.